container ship. The container ship is the machine that turned the ocean into a conveyor belt, and it reduced the cost of global trade by 90% in under 50 years. The largest examples, called ultra-large container vessels, are 400 meters long and 61 meters wide, and they carry over 24,000 containers at a time. If those containers were placed end to end, they would stretch 140 kilometers. At service speeds of 22 to 25 knots, a single ship burns up to 400 metric tons of fuel every day. The hull is divided into vertical steel cells that stack containers by gravity alone, with no mechanism required to hold them in place. Before containerization, loading a ship required hundreds of dock workers and days of labor. Today, the same volume moves in hours. The container ship made just-in-time manufacturing possible across every continent simultaneously. Dry bulk carrier. The dry bulk carrier is the vessel that feeds steel mills and power stations, and it moves more raw material per voyage than any other ship type on Earth. The largest examples, called Valemaxes, carry over 400,000 deadweight tons of iron ore, coal, or grain through ocean routes that smaller vessels cannot service. A single load contains enough iron ore to produce the steel for 3 Golden Gate bridges. At the loading terminal, conveyor systems pour cargo into the open holds at 13,500 tons per hour, filling a space as deep as a canyon. These ships travel at 13 to 15 knots and rely entirely on shore equipment to load and unload, because most carry no cranes of their own. The greatest hazard they face is cargo liquefaction, where moisture in the granular material turns the entire hold into a dense fluid that shifts with the ship's movement and can capsize the vessel within minutes. LNG carrier. The liquefied natural gas carrier is the most thermodynamically demanding cargo ship ever built, maintaining its cargo at minus 163 degrees Celsius throughout a voyage that can last weeks. At that temperature, natural gas compresses to 1/600th of its original volume, which is what makes ocean transport possible at all. The 2 primary containment systems are spherical aluminum tanks that sit above the deck and membrane tanks made from 0.7 millimeter stainless steel, supported by the hull itself and insulated by perlite-filled panels. If the liquid cargo contacted the regular steel hull directly, the metal would shatter. Some vessels burn their own boil-off gas, the fraction of cargo that evaporates naturally, as fuel for their engines. A single Q-Max carrier, the largest class in service, holds enough thermal energy equivalent to 50 nuclear weapons. These ships operate exclusively between secure regasification terminals, where the liquid is warmed back into gas and fed into national grids. Roll-on, roll-off vessel. The roll-on, roll-off vessel, called a RoRo, is the ship that made the global automotive industry economically viable, and it functions on a principle so simple it requires almost no explanation. Vehicles drive on under their own power through stern ramps rated to 375 tons, park on one of up to 14 internal decks, and drive off at the destination. The largest pure car and truck carriers hold 8,500 vehicles across 71,000 square meters of internal deck space, the equivalent of 10 football pitches stacked inside a single hull. Walking every lane on every deck of a large carrier would cover 12 kilometers without leaving the ship. The cost of shipping a car across an ocean is roughly 1% of the vehicle's retail value. The engineering vulnerability specific to this design is called the free surface effect, because the car decks run the full length of the ship without compartmentalization. Any water that enters spreads instantly across the entire level, creating a shifting mass that can destabilize the vessel faster than a crew can respond. Semi-submersible heavy lift vessel. The semi-submersible heavy lift vessel is a ship that sinks itself deliberately, and that is the entire point. To load cargo, it floods its ballast tanks until its main deck sits 16 meters below the waterline. Floating structures, oil rigs, naval vessels, entire dry docks are then towed into position above the submerged deck. The ship then pumps out its ballast tanks, rising slowly until the cargo rests clear of the water. The largest vessels in this category can lift structures weighing over 76,000 tons in a single operation. The ballast pumps move 3,300 cubic meters of water per hour during the loading process, and the entire operation requires 12 hours of precision to ensure the cargo is centered before the deck breaks the surface. If the load distribution is incorrect when the deck rises, the vessel can tip and crush the structure it is lifting. Without these ships, oil platforms built in sheltered construction yards could not be delivered to their deep-water operating sites. Chemical tanker. The chemical tanker is the most technically dense cargo ship afloat, carrying up to 50 different chemical grades simultaneously without any of them making contact with each other. Every single tank on a Type 1 vessel has its own independent pump and independent piping system because a single drop of residue from a previous cargo can destroy a multi-million-dollar shipment of an incompatible product. The tanks are built from 316L stainless steel to resist acids, and IMO regulations require the most hazardous cargo tanks to be positioned at least 1/5 of the ship's beam inward from the outer hull so that a collision breach cannot reach them directly. These ships are significantly smaller than crude tankers, but they operate under a complexity of protocols that no other vessel type matches. They carry the chemical precursors for plastics, pharmaceuticals, and fuel additives. If they stopped operating, most of the manufacturing processes that sustain industrial economies would begin to fail within weeks. Livestock carrier. The livestock carrier is the most biologically demanding ship in commercial service, moving up to 75,000 sheep or 20,000 cattle across ocean corridors in conditions engineered to keep them alive. The ventilation systems run at 40 to 60 air changes per hour to remove ammonia and body heat from the decks, and onboard desalination plants produce over 500 tons of fresh water daily to supply the animals. Automated feed distribution systems move pellets through pipes and screw conveyors to thousands of individual troughs across 10 or more decks. In terms of the number of living beings it carries, the largest livestock vessels are the most populated self-propelled structures on Earth, carrying 10 times the biological load of the world's largest cruise ships. They operate primarily on the Australia to Middle East corridor, through the Red Sea and Persian Gulf, where captains track heat stress data to avoid pockets of humidity, where animal body heat cannot dissipate and mortality rates spike. Crude oil tanker. The crude oil tanker exists at a scale that eventually outgrew the planet's own geography. The largest tanker ever built, the Seawise Giant, was 458 meters long, longer than the Empire State Building is tall, and 2.2 times the length of the Titanic. It carried 4 million barrels of crude oil and had a turning radius of nearly 2 miles. Ships at this scale cannot use the Suez or Panama canals and must route around entire continents. At service speeds of 15 to 16 knots, the largest active VLCCs carry between 2 and 3 million barrels per voyage, enough to fuel a mid-size economy for several days from a single delivery. Modern construction requires a double hull, an inner and outer steel layer with a void between them, so that a breach of the outer shell does not immediately release cargo into the ocean. Before double hull rules became mandatory, single hull tanker groundings released millions of barrels of crude and reshaped international environmental law. Refrigerated cargo ship. The refrigerated cargo ship, called a reefer, solves the problem of biological time, and it does so by treating the entire cargo hold as a single managed atmosphere rather than a collection of insulated boxes. The holds are pressurized and chilled, with air circulating upward through deck floor gratings at 60 to 90 changes per hour, removing the heat that ripening fruit generates continuously. Operating temperatures range from plus 13 degrees Celsius for bananas down to minus 30 degrees for frozen cargo. And the ship's white exterior is not a branding decision. It reflects tropical sunlight to reduce the thermal load on the refrigeration system. These are among the fastest cargo ships in service, running at 20 to 22 knots to minimize the time perishable goods spend at sea. Before dedicated reefer fleets existed, tropical fruit arrived in temperate markets decayed or not at all. The reefer made fresh banana, pineapple, and mango available year-round to populations in northern latitudes, permanently altering the nutritional range accessible to ordinary consumers. Multi-purpose vessel. The multi-purpose vessel is the only cargo ship designed around the assumption that the next cargo will be completely unlike the last one. Its defining feature is the tween deck, a removable internal deck that can be installed, removed, or repositioned to configure the hold for containers, bulk grain, project equipment, or any combination of the three within a single voyage. Onboard cranes capable of lifting 200 to 500 tons allow these ships to operate at ports with no shore-based infrastructure at all. Their cargo capacity typically runs between 500 and 2,000 TEU equivalent, well below the dedicated specialists. But that is not the point. These vessels carry wind turbine blades to islands with no container terminal, mining equipment to inland rivers with no crane, and general goods to developing ports that see one ship a week. They are not the most efficient ships in any single category, And in an industry built around optimization, that is precisely what makes them irreplaceable.